Okay, if you have not used or heard of scientific notation, whether it's in math class or science class, you will. This is probably one of my favorite topics because it's so simple and pretty much anyone can pick up on it. Again, it's not a tricky concept. I'm going to go through all these notes in just one video because it's really that quick and simple. And I think after you see a few examples, it will probably make sense to you. So scientific notation, we're going to talk about using it with very large numbers. So again, thinking about, if you look at example 1, we're going to be talking about space and distances, as we know is very large when we're talking about space. We're also going to be talking about very small numbers. So, and again, we'll see an example of, think of a body cell, some type of cell in the human body or any type of object in nature. Those are very tiny. So the reason for scientific notation is so that you can have a short, and it's not even an estimate, it's an exact number, but a shortened version of it. Because think about it, if you have a number that has, 20 zeros in it, that's very easy to make a mistake as you're going along with your math. Again, not that this is something that you would necessarily use as an 8th grader, but think of a lot of, again, it's called scientific notation. So a lot of scientists, a lot of people in the medical field, a lot of people dealing with really anything with, again, these large or small numbers, this is a very simple concept for them to be able to use to make sure they are accurate with their numbers. Okay, so again, that's why we use scientific notation, just to give a shortened version of the exact number. All right, so let's look at this first one. Louisa is researching the approximate distance between Earth and the Sun. Her father told her that the distance is 9.296 times 10 to the 7th power miles. In an astronomy book, she found the following. So in the book, let me get my pen here. In the book, this is what she found. I guess I should have maybe used a different color. Try this. This is what she found. What we want to figure out is who's correct. Is the book that she looked in correct, or is her dad correct with the number that he gave? Let's see if I can change it here and scroll a little bit. Okay. All right, so Louisa's father used what we call scientific notation to express the approximate distance. Because again, the distance is so great, it's a very large number. And again, you don't always necessarily have to have a super large number, but again, it just helps from saving from making mistakes as you go along. So I'm going to rewrite what he said. So he said it is 9.296 times 10 to the 7th. Okay, so something with scientific notation. It's very important to remember. It will make your life a lot easier if you can remember this. Whatever the number is that's in front of the multiplication symbol, it will always be equal to the number 1, or it will be less than 10. So it's not going to be like 0.5. That would be less than 1. So it has to be at least 1, but it's always going to be less than 10. So it's 9.2. If it was 92.96, that would not fit the scientific notation. So again, keep that in mind. Another easy way to remember it is it will always go, the decimal will always go after the first non-zero digit. So keep that in mind as we move along. All right, so now let's compare what she found in the book. So what this is called, it's called standard form. Standard form, so again, this was called scientific notation over to the left. Now standard form is just whenever it's what I like to call a normal written number. So like what you see in the picture above. That's called standard form. So here's the number that she gave us. Let me change my color so it stands out a little bit. So she found in the book, oops, I don't know what happened there. She found in the book 92,960,000 miles. And I'm just going to leave the number there without the miles. So here's how you can figure out if these are the same numbers. Again, put the decimal after the first non-zero digit. So that would be right here after the 9. Then you're going to make what I call little humps to figure out how many digits come after that decimal. So again, I'm going to start counting right here at the decimal, and we're going to count 1, 2, 3. Oh, sorry. Let me fix that for you. Try it again. I must be touching something. 1, 2, 3, 4, 5, 6, 7. Sorry, just iPad issues. So from where we put the decimal, there are 7 digits that come after that decimal now. So here's how we can write this in scientific notation and be able to compare. So the first digit was 9. Then we had our decimal. And you're going to write every number that's not a 0 that comes after it. So 2, 9, 6. And then that's when the zeros start. So this is where we're going to set up our scientific notation. So times 10. And it will always be times 10. That's why we're doing this. And then the power, the exponent, is however many digits came after the decimal, which we counted was 7. So again, put the decimal after the first non-zero digit, which in our case was the 9, and then count how many numbers come after it. And it was 7. So you should notice that they actually were both correct. They were both exactly the same. Even though they stated things differently, they ended up being the exact same number. Okay, so let's try the example here. The height of Angel Falls, the tallest waterfall in the world, is 3,212 feet. How do you write this number in scientific notation? So again, that's not a super huge number. That's why I said you don't always need a huge number, but we can still write it in scientific notation. So the first non-zero digit would be the 3, so that's what's going to go in the first box, and I'm going to make that decimal, it's already there, I'm going to make it a little bit bigger. And then you're going to put every number that's not a 0 that comes after it, so 2, 1, 2. Well, we need to figure out how many digits actually come after the decimal. In this case, it's 1, 2, 3, so the exponent, it would be times 10 to the third power. Just like that. And then convince me, why do very large numbers have positive exponents when written in scientific notation? So what it's asking is, why are the exponents, like in the problem we just did, was to the 7th, and then the try it problem was to the third power. Why are they positive and not negative numbers? That's because the larger the number, and when we talk about the number, we mean the original one. So for example, in the space one, we're talking about this 92,960,000 miles. So the larger that number is, the higher the power of 10. Okay. All right, and then moving on to our second example. So this one's the exact opposite, and that's what I mentioned earlier. This one we're actually talking about a red blood cell, which we should know is actually super, super tiny. So I'm going to rewrite the number that they gave us. They actually gave us the width of the red blood cell. So I'm going to rewrite that number. It is 0. And again, this is why we do it, because we have to make sure we use the right amount of zeros. It's 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. And then 703. And if you're wondering where I'm getting this number from, it's in the picture right here. Okay, so we're going to follow the same steps as the last time. We're just going to move in the opposite direction. So again, our goal is to, I'll make a little note, place the decimal after the first non-zero digit So what that means, look at your number. The first non-zero digit is the 7. So that's where we're going to place the decimal. We're going to place the decimal after that digit. And then you're actually going to count from the decimal you already had to the decimal that we have now put in. So I'm going to make that note again. So count number of digits before. Notice that all the zeros are coming before this number now because it's a tiny, tiny number. So before the decimal to determine what exponent you should be using. So I'm going to change it just to black. Okay, so we're going to count from the one that came from the number to the one that we put after the 7. So it is 1, 2, 3, 4, 5, 6. So here's the number. 7 in scientific notation, 7.03. Make sure you get all of those numbers that are not zeros. So we have to include the 03 times 10, and then how many places did we move? From this decimal to the one that we made, it was 6 spots. But here's the difference whenever you have a teeny tiny number, and it's easy to forget, so do your best to think about what you're working with. We were working with a tiny number. Think about what we just did on the last problems. When we had a large exponent, so for example, again, we had the 7 to the 7th power, that was a very large number. Well, here we have a very tiny number. So in order to know that it's a tiny number, the exponent will actually be negative. So it's to the negative 6th power. And this is technically in meters. Okay, so let's try it again with the try it problem. A common mechanical pencil lead measures about and I'm sure you guys have seen this before, 0.005 meters in diameter. How can you express this using scientific notation? So again, you need to put the decimal after the very first non-zero number. So in this case, it's after the 5. Now notice that there's no numbers that come after the 5. That's perfectly fine. That just means when you go to set up your scientific notation, it's just going to be the number 5. And then times 10, and we need to count. So from the original decimal to the one that we put in, it is 1, 2, 3 spots. So that means it's going to be to the negative 3. Remember, we moved from one decimal to the other. And it's a very tiny number. If there's already a decimal in your number, it's going to be a negative exponent. Keep that in mind. And that's technically meters. Okay, now let's look at this last one. So with this last one, we're just comparing what shows up on a calculator. So Kelly used the calculator to multiply large numbers. How can she write the number on her calculator screen in standard form? And I would be willing to bet that most of you have had this occur on your calculator before, whether you were just kind of goofing around and typing in numbers, or if you were trying to do an actual problem and this was the case and you got a weird E. We never use E in math, so I'm sure that could be very confusing unless you thought it was like a variable of some sort. So what the E stands for is exponent. So if that ever comes up on your calculator, the E stands for what the exponent should be. The other thing you should notice in this first part, in the first calculator, is that it says E to the E15. Well, the 15 is positive, so we're going to make a note about that. So since the exponent is positive. So you're going to move it 15 places to the right. Again, because moving it to the right will bring in more zeros and make our number very large. So here's where I find this to be the easiest way to do it. So I'm going to write down what's on the calculator. So we have 3.5. I'm trying to make the decimal kind of small. 3.5. And we just figured out, the calculator told us we need 15 spots after the decimal. So we're just going to do the little hump thing again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I had to make them smaller so I didn't run out of room. Okay, so what goes in all of those missing places is just zeros. So every little hump you have is going to be the zeros. Sorry, that got terrible. So that is your very large number. I'm going to go back in and put decimal, or put commas. 1, 2, 3, comma. 1, 2, 3, comma. So that would be your final number. You're welcome to rewrite it. I think it would be a good idea. I'm just not going to because I'm running out of space during the video. But you should rewrite that number. So that is the super large number. So the reason that the E shows up on the calculator is because your calculator doesn't have this many places to be able to show you that number. A calculator only has so much space on the screen. So that's why the E comes up on the calculator if that's ever happened to you. Okay, so let's try it one more time with this one. So in this case, it's a negative 9. It says E negative 9. So again, we've already talked about this. Change the color. So since the exponent is negative, we're going to move it 9 places, again, because it's a negative 9. So we're going to move it 9 places, but since it's negative, to the left. So if anyone ever gets confused, this is the part where people get confused, I've noticed. So pay attention to what's about to happen. So the first number is the number 8. I'm going to actually write it over here since we have to move to the left. Well, we don't see any decimal there, but if there was going to be a decimal, it's always going to be to the right of the number. Keep that in mind. So the decimal that we're imagining is right after the 8, because you could make it 8.0, and that's still the same as the number 8. So if you need to put a 0 there, you're absolutely welcome to. It does not hurt anything. I'm going to get rid of it, though. So we need to move this 9 places to the left. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you need a new decimal, and again, you're going to fill in all those spots with a 0. So that's your, and I will rewrite this one since I have some more space. That's your teeny tiny number. So 0.1, 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, and the number 8. So that's the number that matches what the calculator would be saying. But again, you run out of room on the calculator. So one other thing that I want you to notice is that, let's go back to the positive exponent where there was 15 after the 15 digits after the decimal. Notice that we already had one number after the decimal, a 5. And how many zeros did we end up with? Should be 14. So to make as you get more used to doing this, to make it a little bit easier on yourself, think of how many numbers are already there. So there was one number after the decimal already, but you know you need 15. So if you subtract 15 minus 1, that leaves you with 14 open spaces to put your zeros, and you should have 14 zeros. Okay, Now, similar thing for the -9. We should have 9 digits after the decimal. Well, if the 8 is already going to take up one of those places, then we should have 8 zeros, which we do. So again, just keep that in mind. Make things easier on yourself as you get more used to this. For the sake of the length of the video, I'm not going to do the try it problems. So take this as your examples, and good luck on your